Okay, 9.2c, we're going to find the x-intercepts of parabolas, which is really find the x-intercepts of parabola of quadratic equations. It says a vertex form, but it doesn't really have to be a vertex form. Okay, but this graph is representing this equation. It went right 5, down 4, just like we learned last chapter. The x-intercepts are where the graph hits the x-axis. This is the x-axis. So one of the x-intercepts is right here at 3, 0. And then there's another x-intercept over here, and that's at 7, 0. Okay, so from a graph, we can just stare at it and identify it very quickly. Okay, now if we want to find it from an equation or algebraically, we let y equal 0 because the y coordinate is always 0, just like on these, and then we solve for x. And now depending on the format of the equation, different method might be the most convenient. Okay, so let's look at this first one. Where the y is, I'm going to substitute 0. Okay, now I have x squared minus 7x plus 10. Okay, because this is in standard form, the easiest way to solve it would be to factor it. Because it starts with x squared, I could factor it fairly easily. So x times x, and what do I times to get 10? 5 and 2, does that add up to negative 7? Let's make it minus 5 and minus 2. Then when I solve that, I get x is positive 5 and x is positive 2, which are good solutions, but we do normally write our intercepts as ordered pairs. So the x was 5 when I plugged in 0. So one intercept is at 5, 0. The other one is x is 2, y is 0, because I plugged in 0 for both. Okay, I'm going to go ahead and do the same thing for the next one. This is f of x equals x squared minus 3x minus 28. Remember, f of x is another way of expressing y when we want to be more specific. So I can still make this equal to 0. Okay, now again, because this is in standard form, factoring for now is probably the easiest way to go. And because it starts with x squared, I should be able to factor it. Okay, if this is negative 28, what do I multiply? 7 and 4? But it has to add up to negative 3, so let's go with negative 7 and positive 4. I'm going to go ahead and solve for my x values. I get x is 7 and x is negative 4. If I was solving, those are good solutions, but because we're representing x-intercepts, we want to write them as ordered pairs because they're points on the graph. So x is 7, y is 0, is one of my intercepts, and then negative 4, 0 is my other intercept. Okay, let's do 2 more together. Okay, I'm going to still find the x-intercept, so I'll set this equal to 0. Okay, now this was in vertex form, so I see it as x minus 5 squared minus 4 equals 0. Factoring would not be the best method in this case. Because I see this expression squared, I'm going to use square root. But because of the minus 4, I want to cancel that to the other side. So I'm going to go ahead and cancel the 4 to the other side. So what do I get? I get 4 equals x minus 5 squared. Okay, now I'm actually going to flip this around. You don't have to flip it around, but I find some people like to have the squared on the left side. Okay, but either way, I'm going to square root both sides. And I could have done that on the previous step. There's no reason I couldn't have. Okay, the square root of 4 is 2, but because it's quadratic, I'm going to say plus and minus 2 because I should get 2 answers. I'm going to go ahead and add 5. So I get x equals, so one of my answers is positive 2 plus 5, which is 7. And then my second answer is negative 2 plus 5. Negative 2 plus 5 is 3. Okay, if I were just solving for x, those would be good answers, but because I want to represent intercepts, x-intercepts, I'm going to say x is 7 when I plugged in y is 0. And then x is 3 when I plugged in y is 0. And if I graphed that function, these would be the actual intercepts, which would help my graph be more exact. Okay, let's do one more. Okay, let's see. This one starts with f of x. Remember, f of x is just a different representation of y. So I'm going to go ahead and set it equal to 0. Okay, now because it has this part squared and it's not in standard form, I'm going to use square root. Now you can, there's nothing wrong with the way the equation's set up. Some people don't like the 0 on that side. So if you want, you can move the 0 to the other side because it doesn't make a difference. Okay, but either way, I want to get the square root by itself, so I'm going to subtract the 28 on both sides. Let me see what I have left. 0 minus 28 is negative 28, but I don't want that negative 7 there, so let me go ahead and divide negative 7. Okay, x plus 9 squared equals negative 28 divided by negative 7 is positive 4. Okay, I'm going to keep going. Square root. X plus 9 equals positive negative the square root of 4 is 2. Okay, let's go ahead and find the values of x. I'm going to subtract the 9. So I get x equals positive 2 minus 9 is negative 7. Negative 2 minus 9 is negative 11. Okay, but remember, each of these x values represents a x-intercept. So I have an x-intercept at negative 7, 0, and I have one at negative 11, 0. And if I graphed it, I would actually be able to confirm that this is correct. Okay, go ahead and try the practice problems, and then check your answers at the bottom, or check the calendar for the solutions with the work.